In this lecture, we are going to solve some examples for and do the state reduction on some state tables. So example 1, minimize the number of states in the following table by partitioning. Okay, here is the table. We see that we have 5 states, and based on what we discussed in the last lecture, we need 3 flip-flops to implement this circuit. Let's see if we can reduce the number of states in this table so we can implement it with 2 flip-flops instead of 3 flip-flops. Okay, so now we are going to solve this state. First of all, if we say P0, even before P1, which was the first state, if we put all states next to each other, and for x equal to 0 and x equal to 1, we write the output of each state. So if we are in a state A and input is 0, the output of next state is 1. Okay, so we say 1 1 1 0 0 0 0 0 1 1. So this one is the state 0, P0. So now we are going to build P1, find P1 by placing the states next to each other, which generate this exactly identical output for any input. So here we see that by chance, the first 3 states have exactly same outputs, and the next 2 states also have same output. So for P1, we can say, we can just partition from this point and say P1 is equal to A, B, C in one block, D and E in other block, because they have identical outputs. And now in P1, we find the next state of each state and then do our comparisons. So if we are in state 1, x is 0, next state is C. If we are in state B, x is 0, next state is C. If we are in a state C and x is 0, next state is B. So we complete our next state parts. Okay, when we got to this point, we compare all next states one by one to see if all states in here that I just showing with a red circle belong to a single block. Yes, C, it has C, C, B. So we see that C and B are like belong to a single block. So we can say these group of outputs belong to a single block. No matter which block, this block or this block, just a single block. Okay, so let's continue. B and E. Okay, it has B and E. Does B and E are in the single block? No, B is in this block, E is in this block. So B and E are not belong to single block. So we just show it with another color. D and E. D and E belong to a single block. A and B, also A and B are here. So A and B belong to single block. So we see that the only group that doesn't that states doesn't belong to same block is B, E, E. So here we need to separate them. We need to separate them and move to P2. So for P2 we say A, B, C, D, E. Again the same story, x is equal to 0, 1. We just copy whatever we have here to the next P. So we have C, C, B, B, E, E, D, E, B, A. And again we do our comparison. So we see if, of course, C belongs to a single block because it's one state. So one state belongs to one block. The same thing for B. What about C and B? C and B again belong to a single block, which is here. EE, okay, belong to a single block. DE belong to a single block. And BA, what about BA? In P1, when we check the BA, they belong to a single block. But now, after separating these two blocks, we see that B and A are not in the same block anymore. A is in this block, B is in other block. Okay, so we need to again separate these two, split this block to two blocks. So then we again move P3, it's A, B, C, D, E. Again, the same outputs, x is equal to 0, 1, C, B, C, B, E, E, D, E, B, A. And now if we compare or check these states, we see that all of them are single blocks, or if they are not single blocks like C and B like this, they belong to a single block. So there is no blocking needed anymore, and if we continue we don't need to make more blocks. And for P4 we have the same order. So now we see that P4 is equal to P3. P4 is equal to P3. So at this point we'll stop, and what's the conclusion? We have A, we have D, we have E, but still we have B and C in a same block, single block. So the conclusion is B and C are equivalent. B and C are equivalent. We can ignore or delete one of these two states. So of course, by looking to this state table, it seems that B and C are different because for x equal to 0, B goes to C1, but C goes to B1. It seems they are different, but by partitioning, we saw that there are identical. Okay, so they are same. So this is the partitioning method to find the state reducted or states after minimization. So we say the final state P4 final partition is A, we put in a parenthesis, so it means that A is not equivalent with any other states. We put B and C in together, D in a single parenthesis, and E. So this one is our output, and it says that B and E are equivalent. B and C, sorry. B and C are equivalent. Now that we got to this point, we can simply replace C with B or B with C in our original table. So if we back to our original table, we are going to remove state C. Okay, and we also can remove a state B. So this time we have 4 states. A, B, D, E. We don't have C anymore. And anywhere that we have a C, like here, we replace it with B. So we say B1, B0, B1, E1, sorry, E0, D1, D0, B1, E0, and A1. So this one is the solution of this problem, and we reduced we reduced the states of this table. Okay, so let's see one more example. So here example, we have this table. Okay, x01, A, B, C, D, E, F, G, H, E0, D0, A1, F0, C0, A1, B0, A0, D1, C0, C0, D1, H1, G1, C1, and B1. We want to use partitioning to minimize this circuit. So we'll start from P0. So P0, we write all states and show their outputs as a function of input. X is 0, X is 1. So the outputs are 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1. These are outputs. So this is P0. For P1, we put the states which have same outputs. So we see that A and D have same outputs. B and E have same output. C and F have same outputs. And finally, G and H have same outputs. So we need to put those states with same outputs in same block. So we start from A. So we say A and D together. So one block. B and E together. This is the second block. C and F together. And G and H. Now that we reach to P1, we need to write the next states as a function of inputs. So using a table, we see that the outputs, not the input, the outputs are E, B, A, D, C, C, H, C for x equal to 0. For x equal to 1, outputs are D, A, F, C, A, D, G, B. Okay. Now it's time to examine and see if the outputs of each block belong to single block. So we start with E and B. E and B belong to a single block. D and A belong to a single block. A and D belong to single block. F and C the same thing. C, C of course. A and D the same thing. H and C, they are not belong to, they don't belong to same block. H is in this block, C is in this block. So they are not in the same block. What about G and B? G is in this block, B is in this block. These two next states also are not in the same block. So what we can do, we have to split this block to two blocks like this and write P2. P2 is A, D, B, E, C, F, G, H. For x equal to 0 and x equal to 1, the next states are EB, DA, AD, FC, CC, AD, HC, GB. Be careful when you create a new blocks. You have to examine all blocks again, because they may belong to a single group here, but after splitting a block to two blocks, they are not in the same block anymore. So we need to examine all combinations or all states again. So what about E and B? They belong to same block. D and A, the same thing. A and D, the same thing. F and C, the same thing. C, of course. A and D, and this H is a single state, of course, belongs to a single block, and that's it. So no more blocks. Okay, so we keep here. We say AD, BE, CF, GH, and we stop at here because P3 is equal to P2. So we stop and we say the function is equal to, not the function, just P3 is equal to A and D together. They are redundant. B and E, redundancy. C and F, the only two states that are identical are G and H. Now we need to draw a new table here with reduced states. So here we draw a new table. Okay, of course, how many states we will have? We will have 1, 2, 3, 4, 5 states. So we show 5 states here. X01, which states? Let me write it down here. Write it here. It was A and D, B and E, C and F, G, H. So we remove D, state D, we remove a state E, we remove a state F. Instead of a state F, we replace it with C, we replace E with B, and we replace D with A. So we keep other states A, B, C, G, H. For A, we say A is E0, E0, but E is replaced with B. So we write B0. D is replaced with A. So instead of D0, we write A0. And we, based on this eliminations, we update our table. So A0, A1, C0, C0, A1, H1, G1, C1, and B1. So this is the final answer. Okay, let's see one more example. So this example has 2 inputs. So far our examples had 1 input. So input X. 1 input means 2 possible combination. X is 0, X is 1. But if we have 2 inputs, there are 4 different combinations. Okay, so let's see one example with 2 inputs. So example here, and this is the table. Okay. Okay, so we have x0, x1, two inputs, and we have 8 states: state A, B, C, D, E, F, G, and H. And the inputs are 0, 0, 0, 1, 1, 0, 1, 1. Okay, so let's fill the table. D0, D0, F0, A0, C1, D0, E1, F0, C1, D0, E1, A0, D0, B0, A0, F0, C1, F0, E1, A0, D0. It's really pretty large table. D0, A0, F0, G0, G0, A0, A0, B1, D0, E1, A0. Okay. Now it's time to start our solution by drawing P0, by writing P0. It's A, B, C, D, E, F, G, and H. Okay, so inputs x0, x1 is equal to 0, 0, 0, 1, 1, 0, 1, 1, and the outputs are 0, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, and for 1, 1 input we have all the zeros. And now we need to find we need to group states with identical inputs. So outputs are A, D, F, and G. It's one group. B, C, E, and H is one group. Okay, now that we know we have two groups, let's just write P1. So in P1 we write A, D, F, G in one group, one block in fact, B, C, E, H in another group. And the same thing for the inputs 0, 0, 0, 1, 1, 0, 1, 1. This time we write the next states, not the outputs. The outputs only for P0. So next states, it's D, 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 G. In fact, we go here and we see, for example, the next state of A for input 0 is D. So we write D. The next state of C for input 0 is C. So it's in this way we fill this table. C, 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 B, D, B, D, G, D, D, F, D, F, A, and E, 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 E for the last input, A, F, F, A, F, A, A, A. Now it's time to examine. D and G are in a single block. C and B are in a single block. D and F are in a single block. E, of course, single block. F, A, single block. A, F, single block. F, A, F, single block. But D, B, D, G, it's not in the single block because D is in this block. B and G, D is in this block. B and G is in this block, but B is in other block. Okay, so we need to fix these states. Okay, so what we can do, we move to P2, and because D, D, G are in the same block, we put them together and remove, change the location or position of this state. So we write it this way. Let me write it down. So we say A, F, G, A, F, G, A, F, G. Okay, we put them together, and here I put D, because D is like D has different outputs. So for the, and we add a block here. For the rest of them, we keep it as is. Now it's time to write the outputs. So for x is equal to 0, 0, 0, 1, 1, 0, 1, 1. Let's write it. So it is D, D, G, D, D, G, F, A, F, A. Okay, for D is D, B, A, F. But here everything is similar to previous partition, so we just copy everything. Okay. Now that we reach to this point, again we examine all states. D and G are not in a same single block. G is here, D is here. So they are not. Again, D and G, they are not. FA, they are in the same block. AF, same block. Single block, not same block. Single block. These are, of course, same single block. C and B in single block. DFD. Now there are, before they were in a single block here, but now they are not because we separated D and F. Okay, so D and F are not in a single block. E single block. AF single block. So we need to create more blocks. Of course, D and G are not in single block, so we create another block or split this block to two blocks. And here DDFD, so let's just put B, C, H together, and E will separate E because E has a different output, but B, C, H, all of them have D. So we keep B, C, and H together and put E in a separate block. So it's like this. So let's just write P3. So we have A, F, G, D. For X is equal to 0, 0, 0, 1, 1, 0, 1, 1. You see, for this table with two inputs, the solution is kind of more difficult than like one input. So we need so many different combinations that we need to take care of. Okay, so we write the outputs. So DD, G, DD, G, FA, A, AF, AF, A. For D, we have DB, AF. For B, we have CD, EF. For C, we have CD, EA. For H, we have BD, EA. For E, we have CF, EA. Now, we again examine all states in each block. DD, single block, DD, single block, AF, FA, AF. Of course, these are single block, all of these. CB is a single block, DDD, EEE, FA is in a single block, and this one. So no more partitioning. So P4 will be equal to AF, GD, BCHE, and we see that here P4 is equal to P3. So stop, and the simplified version is AF, G, D, B, C, H, E. We see that we have more than two identical states in this example. So let's draw the reduced table. We replace F with A and C with B and H with B. So if we draw the reduced circle as table, we will have this table. We reduce the number of states from 8 to 5 by partitioning method. So 0, 0, 0, 1, 1, 0, 1, 1. So we keep A, we keep B, we keep D, we keep E, and of course G. And the outputs are equal to D0, D0, A0, A0, B0, D0, E1, A0, D0, B0, A0, A1, B1, A0, E1, A0, G0, G0, A0, and A0. And this is the reduced table. Okay, let's look to the solution all in a single page. Okay, and this is the solution of our problem. Okay, that's it for partitioning. And it's all I have today for you. So we continue in the next lecture.